Thank you very much. It's a great pleasure to be here for the opening ceremonies of this academic year. I'm happy to see so many familiar faces, friends of longstanding and former colleagues in the audience, and I'm happy to see all of you students. And I want to echo the sentiment that was expressed by the previous speaker and tell you that you are indeed very fortunate to have chosen this program, this academic program, because here you have the opportunity to be taught by some of the most distinguished scholars in the field. This is truly an outstanding faculty, one you should be proud to be associated with. I'm also happy to have the opportunity to talk to you about some research that's research in progress. It's at an early stage, it's far from finished. But it addresses what I think is an important issue, something I call the demographic deficit. Now, there's a lot of talk about the importance of demography, and it circulates in a fairly loose form in the press and economic research and so on. It occurs constantly in many contexts. Most recently, for example, a lot of the press coverage of the wave of immigrants coming to Europe from North Africa and the Middle East has talked about how these immigrants could actually help Germany because Germany faces an aging and shrinking workforce, and that this wave of immigration could actually increase German prosperity. And many countries throughout history have benefited from immigration. But the key thing is to understand, it seems to me, what exactly is the role of population growth and demographics in understanding how the world is evolving. So another context in which discussions of demographics frequently arises is in the discussion of secular stagnation. Now, I won't read to you this slide. Larry Summers has labeled this slowdown in growth that we have observed in much of the world secular stagnation, and these are some of the reasons he gives for the slowdown. But the essence of secular stagnation is a chronic excess of savings over investment and the falling natural rate of interest. And one of the ingredients driving this process, in this argument anyway, is the declining population growth. Another prominent figure in this discussion is about declining growth is Robert Gordon, who argues that demographics, not just declining productivity or innovation opportunities, is a key element of the slowdown. So what is this slowdown? Well, this graph is taken from some other work that I did. It shows the path of the growth rate of GDP for Japan after post their 1990 crisis, their collapse of the asset bubble in Japan, and for the US and Europe post 2009 collapse. And so in Japan, you see the consequences of their collapse was a lost decade or decades. In Europe, you see what seems to be a lost decade ensuing in the aftermath of the financial crisis. In the US, although it's growing at a very low rate relative to historic experience. So demographics is cited as a key factor in these slowdowns, but how important a factor is it? We all know in some visceral sense that populations in many parts of the world are aging, but how important is that, and why is it important? What is the mechanism by which changing demographics affects economic growth? So what I'm going to do is I'm going to give you a little bit of a story about that today, and I'm going to start by talking about some facts about demography. Then I'm going to do some what we call in economics growth accounting. If you're not familiar with it yet, you will be by the end of your master's degree course, I'm sure, to tease out what the impacts of demographic changes on growth are. And then I'm going to follow that by I'm going to use very established theory to do that. It's called the solo growth accounting procedures. And these results are just basically arithmetic. But in fact, they're quite striking. And then, if I have time, I may not, I'll try to describe some elements of a model that would capture this, and then I will describe, even if I don't talk about the model in any detail, some results about how this model can be used to project the effects of demographics into the future and give you an estimate of how big the impact of demographic changes is on growth for Japan, which is the only country for which I've completed the simulation so far. Japan, I'm going to focus a lot of my discussion on because that's as far as I've gotten, but also because to some extent it's the most interesting example to start with. An aging and shrinking population that has an aversion to immigration, which is one of the tools that you can use to address demographic issues. So let's first look at a picture of the age distribution of the population for a few countries. This is as of 2013. And what's notable about this is Japan, which has a much bigger left tail in this distribution. That is many older workers. And the transition to that started much earlier. You can see China and the US on this graph as well. Another picture that captures some of the concerns about demographics, people's concerns about demographics. This is a plot of what's called the dependency ratio. So the dependency ratio is the ratio of the population that are between 0 and 14 or 65 and older relative to the total population. So as the dependency ratio rises, that means that the population is supporting a larger number of people who are unable or are less likely to be working. And you see again how extraordinary the path of Japan is. Japan is the line in blue. Their dependency ratio started taking off in the 1990s, and these are projections out to 2050 based on UN population data, and it's projected to get just enormous. Other countries which have similar kind of dire projections are Italy, for example, which has a dependency ratio that at some point gets worse than Japan. And you see that Europe as a whole has rising dependency ratios. The US tapers off, China increases, India's in a period of decline for at least some time. So how do we get to that? Oops, sorry, I went too fast here. Well, we get to that in two parts. One is declining fertility. Okay, so this shows you the picture of fertility over time for the US, Europe, Japan, China, and India. And you can see that in many of these countries it declined early and has continued to decline. Europe has declined a lot. Countries that are below, that have fertility below 2, they're basically below replacement rate. So absent immigration and other things, they're going to experience shrinking populations. You can see that the US is not so bad, China not so bad yet, but Europe and Japan are declining quickly. This gives a breakdown for Europe by sections of Europe, and pretty much across the board in Europe, fertility has fallen below replacement and is projected to remain so. So that's one part of determining the relationship. The other part is life expectancy. At the same time that fertility is declining, people are living longer. So life expectancy has increased, in some cases dramatically. And so once again, Japan is the most interesting example because they had the largest decline in fertility, and they've had the largest corresponding increase in life expectancy. But in all countries, life expectancy is increasing. Now, this is clearly important because it's going to drive the age composition of the population in these countries. And I'll get to that in a minute and talk about why that's important. So this is life expectancy. And again, in Europe, there's not much particular notable about this except Eastern Europe, in which life expectancy has actually at various points declined and is not rising as quickly as elsewhere in the world. The most striking picture to me is this one, which shows the distribution of life expectancy at various points in time across all countries. And so the furthest right, the yellow path, is the distribution of life expectancy in the most recent data across all countries. So if you compare that with the black line, which is the distribution of life expectancies not that long ago, 1965 to 1970, back then, the distribution of life expectancy was bimodal, meaning there are a lot of countries where life expectancy was short. Life was short, mean, and unsatisfying in a lot of those countries. And that distribution has shifted fairly dramatically to the right. And to some extent, it's a lot less bimodal than it used to be. So there are many fewer countries where life expectancy is very short. And I always take that as a kind of a global evidence that development is, in some sense, development efforts are working, that people are living longer, and we're at least dealing with the causes of mortality better. So life expectancy and fertility translate into the age structure of the population. And so now I want to show you some pictures of what I call the cohort structure of the population. And that's going to turn out to be critical to the research that I'm doing. So this is the cohort distribution for the whole world. And what you see, so this particular picture only projects it out to 2040. Because of data limitations, I couldn't project it further. But it shows you that by 2040, the age distribution, the cohort distribution of the world's population is going to have shifted. Will have flattened out and have a much longer right tail, meaning simply that there are very many older people in the world by 2040, that these blue spikes rise. And there are many fewer younger people and fewer prime age workers than before. So let's look at some individual countries. This is the projected cohort distribution for the US. And this is projected out to 2100, so it's much bigger. And you see that by 2100 that the decline in young workers is fairly pronounced, and young cohorts is very pronounced, and the rise in older cohorts is very pronounced. So this uses projected fertility and projected changes in mortality to get the population and the age structure, and then estimates the transitions, and that gives us the age structure of the population. So this sort of steady shift towards having many people in these older cohorts that go up, the largest one is 100, or the far right tail is 100 plus. There were essentially no entries in that in earlier years. This is the cohort distribution for Germany, and you can see that Germany actually is changing relatively quickly. It's already changed to having a much older cohort structure, and it's going to continue to do so. This is the projected cohort distribution for Italy, and what's striking is how dramatic the change in the left-hand tail of cohorts is, and how quickly these right-hand cohorts are increasing. This is the projected cohort distribution for Spain. It shares a lot of the characteristics of Italy, and you're going to have many fewer older people to deal with. So, and the age distribution of the population is flattening out, and you see many fewer prime age workers by 2100, by the next century, and many more older people. And then lastly, this is the projected cohort distribution of Japan, and this is probably even more striking because of how quickly Japan changed. Japan has already got a lot of older workers in older cohorts, and already gone through this dramatic shift to the right in the cohort distributions. Now, the evolution of these cohorts is going to be of critical importance for what we do, because the basic logic is this: as the cohort distribution of the population shifts out, the number of workers who are later in their life cycle increases. And we know a lot about how workers vary their work effort over their life cycle. They vary their labor supply decisions. And we're going to talk about two margins of adjustment. The extensive margin, which is the decision to work or not to work, and the intensive margin, which is conditional on working. How many hours are you going to work? So the former is the decision to participate in the labor force, and the latter is conditional on participation. How much does one work? And we, not surprisingly, as workers get older, labor force participation declines significantly, and as workers get older, the hours of work that they put in also declines significantly. So I can come back to talking about demographics in a bit, but first what I want to do, I have a limited amount of time. It's fast running out. I'm going to stick to schedule. I planned this as a 45-minute to an hour talk, and I saw on the schedule I have 25 minutes, but I'm going to almost meet 25 minutes. So I'll talk about these things, but I want to take a first crack at providing some estimates of this, what I call the demographic deficit. And the device I use, as I said earlier, is a tool that's familiar to all economists. It's due to Robert Solow. And Robert Solow wanted to understand how much of economic growth was due to capital deepening, that is more capital per workers, how much was due to increases in the number and quality of workers, and how much was due to productivity, a concept called total productivity. So Solow wrote down a production function which described the production of output as a function of capital, labor, and productivity, used estimates of the share of capital in output that were well confirmed by many researchers in the data, and then used data on output, capital growth, labor input to decompose the sources of growth. And since all those were observable but productivity was not, he estimated productivity as the residual of this growth accounting. And that was his big insight. And as I said, it's just arithmetic, but let's apply some of that arithmetic to the demographic problem. Here I consider a production function in which output is a function of productivity, I call A, the ratio of capital to labor, raised to the power alpha, which is the share of capital in output, population, so I started off by writing this as output per capita and then moved population to the right-hand side, and then labor force over population, which is labor force participation, and then hours of work raised to the 1 minus alpha. So this is the extensive margin, and this is the intensive margin of adjustment. And once again, because these things are all observable data, we can calculate productivity as a residual. And so using what economists do, basically the arithmetic of growth, we take logs and then we can write, we can decompose the growth of output as the growth in output is equal to the sum of the growth in productivity plus alpha times the growth in the capital labor ratio plus the growth rate of population plus the growth rate of labor force participation plus 1 minus alpha times the growth rate of hours per worker. And that's the decomposition that we use. I use data from the Penworld table, the latest versions for this talk, and I'm going to look at, in particular, I'm going to look at Spain, Italy, the US, and Japan. So this is the growth accounting for the period from 1990 to 2006. Now, I'm going to look at two periods, 1990 to 2006, and then 2007 to 2011. That's a little arbitrary, but it turns out to be interesting because you can see the effects of the demographics kind of kicking in more forcefully in this breakdown. The 1990s were the lost decade for Japan. It's reflected in their very low growth rate of output. In the United States, the growth rate was about at historical long-run averages. Spain had very high growth rate. Italy was fairly low. The remarkable thing about Spain is that it had a very high growth rate in spite of having very low total factor productivity. And that's not unsurprising probably to a lot of economists. And most of the growth rate was coming from increases in labor force participation. So the last three terms here are the contributions of demographics to growth. So in the case of Japan, the contribution of population growth was negative. Their population was already shrinking because of demographics. Now it's actually shrinking at a much faster rate. Japan is, I think, in the latest data, losing a population at a rate of 1 million people a year. Labor force participation was declining, and hours of work were declining. So adjustments at the intensive margin. So these three things add up to a significant drag on economic growth. And the question is, can we explain? These are the demographic factors. I'll talk a little bit more about the question in a minute. So this shows the same kind of calculation for the period from 2007 to 2011. And so what's notable is that none of these countries were growing. US maybe minusculely. The bigger question is how fast were they shrinking? Productivity was declining in both Italy and Spain, but let's look at the demographics for Japan. So population growth was contributing some negative headwind to their growth. Labor force participation was declining, but a big factor was the decline in hours per work. So when you add these three components up, this constitutes more than 1% drag on economic growth. And this is a huge headwind for an economy to face if it's coming, and if it's coming simply because of the aging of the population. That's a big problem. There are a couple other things that are worth noting here that are different, and that is in the US, in Spain, a lot of the drag is from labor force participation. And this is, for the most part, not the effect of aging, but it's the effect of declining labor force participation at all ages, and I'll show you some of that in a minute. But from this, you can calculate what the growth deficit is. So in the period from 1990 to 2006, Japan's growth deficit from demographics was minus 0.8%. Now, Japan currently, bear in mind, is struggling to grow at more than 1%, in spite of massive monetary and fiscal stimulus. So if you're facing a headwind of minus 0.8% and it's going to get worse, that's a big issue. In Italy, the growth rate was relatively, the deficit was small. In the later period, the growth rate deficit from demographics was 1.35%. Italy, it was over 1%. In the US, the growth rate deficit from demographics was 1.5%. But this, as I said, is not aging. It's something else that's going on in the workforce. Okay, so what's the something else? So this shows you labor force participation rates in 1990 and 2010 over the life cycle for the US. And what you see is that labor force participation rates shifted down. So the big puzzle for US policymakers, the big question is, why are prime age workers participating less? It's sort of at a historic low, labor force participation in those cohorts. And labor force participation of older workers has actually increased a bit. But in Japan, that's not the case. In Japan, labor force participation has kind of stayed more or less the same over the life cycle. Now, as you get more and more workers in the tail of this life cycle distribution, then you can understand what the effect of labor force participation rates declining is going to be. It's going to collapse sharply. One last picture, and that is the importance of the intensive margin. So in Japan, in this table, I showed you that the large effect due to changes at the intensive margin, changes in hours per work, and you don't have to do that to see it. You can just look at the data. This is hours of work, average hours of work in the US and Japan. The US has been flat. In Japan, it kind of collapsed beginning in the 1990s. Some of that was legislative changes, but it's just continued to decline as a consequence of the aging population. Now, how much of these growth differences can be explained by their demographics? So if the evolution of demographics is important, we ought to be able to project into the future what these demographic changes and what the future projected nature of cohort distributions, what impact that has for future economic growth. And what an economist wants to do, I'm not going to take you through the model. I'm going to just describe what an economist wants to do to get a good answer to this. And that is, you want to know can we model this as a consequence of individual decision-making, of individual behavior? So can you describe a world that's driven by these demographic dynamics in which individuals are making individual labor supply savings decisions over their life cycle? They face life cycle path of earnings. They have decisions about how to adjust their labor supply at the intensive and extensive margin. These are things we know how to do. And if such a model accounts for the kind of arithmetic we saw in the solo growth accounting, then perhaps we can use that model to project into the future what the baked-in demographics are going to imply about Japan's growth in the future. I'll skip these slides about the model of demography and preferences and so on. Anybody who wants more, I will give it to you. But I will just rush to some conclusions because I'm almost out of time and I'm almost on time. And they are the following. The demographic deficit is potentially a very significant headwind for world's economies. And it's a very important factor in the economies of Japan and Italy in particular. So where this model seems to work best is for countries like Japan and Italy, which have these kind of extreme case demographics, rapidly aging, rapidly rising dependency ratios. So an economic model does a reasonable job of capturing these things. My preliminary estimates for Japan suggest that by 2050, the demographic deficit for Japan is going to be over 2%, minus 2.2%. Now, this is an issue. This is a problem because demographics are baked in. You can't decide, well, at least we tend not to, that we don't want to have so many old people. There's a movie called, what was it called, Soylent Green or something, that imagines people being given these tablets to get rid of the old unproductive workers. Anyway, that's an old movie, horror movie. We don't do that, that's what I'm saying. So we're not going to change the demographics as an act of public policy. So what do you do? Well, there are things you can do. Policy options include encouraging immigration. People have been saying that about Japan for years. The Japanese culture is averse to that. And so they haven't done it, and that's not really part of their plan. You can increase female labor force participation, something the US did a lot over a couple of decades. That's part of Mr. Abe's third arrow of economic reform, is to try to dramatically increase female labor force participation and make it easier for women to both work and have babies. You can change retirement and pension policies to encourage labor force participation later in life to take advantage of improved morbidity, that is improved healthiness of older workers, like myself. We can still work. But the set of policy options for addressing demographic problems are really different from the ones that we normally think of. But they're no less important, particularly when you're facing significant headwinds from something that's kind of baked into the economy by individual behavior. I thank you very much for listening to me today, and welcome.